Oh iya, jadi I had to pay. Terus ini polisi tidur. Terus saya jatuh orang I mean kalau motor aja bisa di-scratch ya. Kalau bisa sih tergantung orang kayak gitu. Oke, kemarin gue sempat bohong guys sih. Bapak tetap bisa. Terus dibawa maksudnya bukan dicoba harus kerjain itu gimana? It should. It must work. Ini banyak keprop dengan mesin luar kan motor pasti. Kan kalau kita itu teknologi dia terpropok akan motor jalan bukan itu itu mereka propok nih dia integrated shit dia kan ada satu MCU sebenarnya kalau kita bikin sesuatu yang bisa dengan kalau warna punya si goyang tol kan udah banyak oke yang bisa nggak bisa taunya pas mau beli crash
where are you gonna get that data, stuff like that. You need to think about that. Don't think about that do like that. But you also need to figure out why you're doing it. That's still not, you just saying words.
Kemarin gue bikin sih nanya kan banyak tuh wacana kayak
okay, then you could frame it as analysis on like using building this hybrid as like what is more efficient, right? And you have to think about it like how do you where do you get the fuel? The process to get that fuel is to produce. The monthly to produce and versus like just pure power. And then you have to look at the energy loss going from one to another. What energy source going from extracting in the ground, how much oil that takes, converting the energy to heat for your food, like transferring that fuel, like talk about the efficiency costs, right? And doing that analysis of how bad it is, you can also do it like if you don't really need that, especially that's why you have all this time until December.
I guess it's narrow down.
Yes. We'll see how accurate it is. But that's really too much. Exactly. Because for me, when I'm developing, I'm doing a full-on analysis, comparing it to a quantum configuration and optimize that. You can do the same thing as well, like full EV versus hybrid. But you need to go into like where you go with that.
Alright guys.
You have to make sure that the data that they got is relevant to the question you need to
lewat.
Di belakangnya ada stiker every family. Tapi sebenarnya kenyataan soalnya kan ya itu sore gue udah siapin bahan.
Yang bisa direalisasi.
Ini di mana di?
Lo masih mau nafas di
Iya.
Iya.
Oh yang gua taruh di sana.
Semuanya orang-orang Jepang, semuanya orang Jepang tuh.
Boleh. Gua mau nge-push apa juga.
Iya tuh tiba-tiba gitu.
Hey, attendance guys.
kayaknya lo cobain dulu.
Susah gitu loh kok ini. Plakat akriliknya namanya sama kata-katanya sama itu aja kayak tahun lalu.
Itu yang tahun lalu.
Ya ini yang tahun lalu.
Tulisannya apa?
Terima kasih dan apresiasi kepada nama
Kalau mau ada diunikin lagi, kasih desain AMD tahun kita.
ya maksudnya kan desainnya kayak seperti ini, maksudnya kasih ini nama sama
Boleh sih.
kata-kata dari kita aja.
Kalau mau apa? Biar referensi yang MD 2023 aja, yang soal bot. Ada tuh di lab kontennya. Kita mau bikin lagi kayak perlu ada buat model lecture. Saya pakai juga buat jadi moderator.
Iya aja pak.
Hah? Iya, makanya. Okay, everybody did that. Excel. Okay, location is on campus. I don't know how to fix it. Try uninstalling and installing it again. See what happens.
Kalau desainnya kan desainnya udah sama
How was your trip? What do you think about the trip to the manufacturing trade show or the packaging trade show? I give you an assignment, right? You're supposed to submit it today.
Yeah.
You all submit it?
Yeah.
Okay. So what's the experience like? Tell me about it. Kita nggak sempat kumpul lagi kan after the trip.
I think it's like what's called. It's good to see all the different to see it in real life. We talked about in class. Nothing was too out of the ordinary. I don't think.
Nothing is what?
Too out of expected. There's not something that
Okay.
novel, right?
Okay.
But, maybe if there is, it's like they didn't really bring it to the business.
Mm-hmm.
But
Yeah.
it's cool to see the integration.
Yeah, seeing it
of
is different, right? And seeing it in action. Otherwise, you'll have to be in the factory to see it.
Yeah.
Yeah.
There was a ton of dupes.
A ton of what?
Dupes.
Dupe?
Duplicates. Duplicates from like so different companies, but they make the same exact machine, the same design, and the same size, and they sell it.
They're competitors, basically,
Yeah,
right?
it was very, I guess, their percent was different. Like, there were many, actually, the problem was, I guess, it was all the same, really the same design, same machine. The prices were also the same. So it was quite
The price is also the
The
same.
price was also the same. You would think because they're competition, they would like undercut each other, but the price is exactly the same.
Well, that's the opening price. It's before negotiation,
Yeah.
right?
I guess that was where I was surprised because the price difference was not, there was nothing for the opening price.
Okay. Okay. What about you? What do you learn? What's new than just seeing it in video?
I get to learn how the machine works even more in depth because I asked the salesman there. But what I found is that mostly the person there is just like salesman literally, so they do not know about the machine. So sometimes
I see. They don't have too technical
they do not know
detail.
the technical knowledge.
But sometimes there are sales engineers who can
there were some
explain.
sales
Right.
engineers.
And to be honest with you, many of you will work as sales engineers. Many of you is probably a better sales than engineer. Let me tell you that. So if you don't feel confident with all the technicalities, all the calculation, you can always be a sales engineer. Job of a sales engineer is to be side by side with the sales guys and kind of explain how the machine works. But you don't have to design the machine, right? So you become sales engineer. Or a lot of the common job is also what is called an application engineer. Application engineer is you have a client come in, and then let's say your company is a company who sells conveyor belts, right? And so what usually happens is that they meet the sales, but then the requirement is gathered, and then they go to the application engineer who then try to select the right product for them, right? Select the right size, the right width, the right material. So that's called an application engineer. Application engineers don't usually go and meet the client directly unless the deal is already closed. So first they make the deal. After the business deal is done, then during the implementation, then you'll be the main person. But during the quotation process, the sales guy will ask you in the office, not meeting with the client directly. So they just get the requirement. So you're the product engineer. And that often happens. You're not the one designing the product, but you will be the one customizing it for the right application. Yeah. So that's why in this course, we often talk about applications because I think the majority of the job you will get into is applications, right? Selecting components. Either you as the user themselves, so let's say your factory is the one who makes stock, okay, that stick wafer, and you need to modify some conveyor. And so you'll be the one selecting components, right? You're not designing conveyor belts, but you're the one selecting the right one. And then you'll have a vendor who actually implements it. Did you guys have the chance to meet like solution providers? Not manufacturer of the like robotic arms, but like solution providers who just do the programming. No? Maybe they look like they are showcasing a robotic arm, but actually they are solutions. So solutions means they're the one who program it for your application, but they're not the one selling the robot. I mean, they sell it as a package, I guess, but they have partnerships with like robotic arms, for example. Did you guys stop by Sunco company? We have a lot of partnership with them, at least used to be. To meet any SU alumni?
Yeah.
Backup? Yeah, we got a lot of our alumni there. Siapa ya? Andy ya? Andy? Gabby, that's right. Yeah, Gabby did her thesis with me. At that time, it was with Faros. I think it was a pillbox automation, like giving the right, dispensing the right pill at the right day, like schedule, you know. Yeah, it was fun. Yeah, so she's working as what? Sales engineer or? Yeah, sales engineer. Any other alumni to meet kawan lama group? Kawan lama? Kawan lama juga ada a few of our students, our alumni. Okay. So yeah, I hope you learned a lot. Now in the assignment, I also asked you to see the other topics that you need to analyze in the machines that you study too. So this is one of them, okay? Because the show, the packaging trade show happens like now. So there is another trade show we should go to. It's called manufacturing trade show. It's even bigger than this one. But the difference is they don't showcase like a whole automation. That's the difference. So they sell like components of it. But it's good to go if you can go. I'll give you the information. It's usually at the end of November. At the end of November or early December. What we want to talk about today is framing design. And a lot of the frames that you see will be from aluminum, right? Wow. Can anyone tell me why aluminum? Not cheap. It's lightweight. It's not cheap. Steel is actually cheaper than aluminum. But steel rust, right? You gotta paint it well, so it doesn't rust. I mean, aluminum will never rust, like forever. I mean, it might be a bit ugly, but most of the aluminum with the nice finishes, they are actually anodized, anodization. So it's coated. It's coated with a clear coat. So if you see some nice aluminum, this aluminum, I don't think it's anodized though. This one looks kind of dull. It's usually, if it looks dull, it's not anodized. But a lot of the flexible frames that you see on the automation machines, the legs and all that, they are all anodized. So it has some coating. Otherwise, it'll be ugly like this. Because aluminum is always oxidized. Do you know that? So there is no such thing as pure aluminum. Once aluminum gets in contact with oxygen, it becomes AlO2, which is aluminum oxide. So it always looks dull. That's why aluminum always looks dull. Shiny aluminum is only when it's molten state. That's why they coat it with some anodized. And you might see some nice anodized aluminum, like blue, red, colored. Yeah, exactly. So, all right. Now, why are we talking about that? Because every machine has to have some frames, right? I mean, it has to stack. So let's see. Well, this is a company. It's called 8020. They make framing solutions. Let me show a few videos here. So this is called flexible framing systems. So they sell these. So you can even use it as a table leg if you want, right? But they are called flexible framing because you just cut it to length and then you just join them, right? So you pretty much buy the pieces and then there are joints to join them and you create a frame. So any machines that you make has to have a frame, right? It has to have legs. How are you going to mount the sensors? And these are called flexible because there are slots here that you can mount anything onto. Sensors, motors, right?
Today, we're going to take a look at one of our more popular user solutions, the custom workstation. Now, the right workstation not only increases productivity, but it reduces. That's when we hey, a workstation. That's been burning about a bit.
Now this one. So these are just different connectors, you see. So this is the connection method where you have a bolt coming from this side and then another cam coming from this side, and then you lock it in place. So there are just different ways for you to connect two pieces together. But let's look at the so if you look at the typical, I mean, we look at many of these, and once you're in the trade show, you also see a lot of these. But notice, like, right? I mean, most of the, you might not pay attention to it because they might be invisible, but all these are flexible framing aluminum pieces, right? So everything has legs. You have to fix everything onto something. Now, there will be custom plates like this, where you have to adjust the roller, for example. This is a conveyor belt, and in order to tension it, you have to loosen the bolt, pull it out, tighten it again, and so the belt becomes tightened. But you know, you'll have plates here and there, but the main structure, the main frame, tulang rusuknya gitu ya, the main frame is these aluminum systems.
There were also a lot of delta robots.
Yeah, we saw quite a few, right? I saw a big one, a pretty big one. And the end effector has this jig that can adjust something like this, right? So it has a jig at the end of it. So yeah, I mean, everywhere you look at the legs, look at how everything is kind of situated or held together, and they're all aluminum flexible frames. Now what I want to show you is the different joining options.
And welcome to T-Slots. Today, we will be talking about our fastener options, the benefits they offer you, and how to know which one will best suit your application. Here are...
Okay, let me ask you before he tells you the different styles. Which one do you think is the strongest?
Third one from the right.
Third from the right.
It's the fourth from the left.
This one?
No.
The third one from the left.
Well, the answer is it depends, right? What kind of load are you seeing? Now, generally speaking, this will be the strongest. Just general loading. If you load it this way, you twist it, you bend it. This will be one of the strongest. It's also expensive because, I mean, that thick of an aluminum, that many holes, you also have to tighten more bolts. But generally speaking, this is one of the strongest, followed by this one. This one you cannot see what's happening, but actually there is a head of the screw. You slide it in, and then you put pakai kunci L dari sini masuk, kencangin, and when you tighten it, it clamps the two together. It's not that strong, but this is one of the cheapest and easiest way. So if you're not looking at a lot of loads, this is not a bad idea. This is also not a bad idea.
Few examples of our fastener options. How do you know which one will best suit your application? Well, let's find out.
Let's start with our fastener options that require machining. For more additional information on the machine, please see our T-Slots catalog. Let's start with the anchor fastener. The anchor fastener is the best connection that we offer. It is durable and it is vibration proof. For projects that require strength and rigidity, these are going to be your best option. The end fasteners are also a great durable option. With only a small machining hole, these offer a very clean look for your application. Next, for our joining plates, brackets, and gussets. For projects that need to be more modular or are more time sensitive, these are going to be your best option.
So the consideration you have to make is whether you're going to tear this down or not, right? If you're going to disassemble it, these are easier to disassemble compared to the ones that the connector is inside.
These fastener options are more versatile and offer easier installation. As they do not have any machining required, they are also more affordable than the machined options as well.
So you don't have to machine anything, you don't have to drill any holes.
These fastener options also can be used by themselves as a standalone option, or they can be used to reinforce the existing machined options as well. And finally, are our no-fab connectors. For projects that require a clean look without the bulkiness of the plates, brackets, or gussets, these are the best options. With the fasteners that sit inside the slots, they can appear unnoticeable at times.
So these connectors sit inside, so it provides a clean look, if it's important.
With similarities to the plates, brackets, and gussets, these can be more affordable options as they require. With similar fasteners that...
By the way, trivial question. How are you going to put those in?
Slide that way.
Do you know how it works?
Slide in.
This little connector there?
You slide it from one side and you slide it the other.
Okay, so
is it a P piece, like a P, and then you slide?
Oh, it's an L. It's an L.
L. So you would go put it into one and then you slide.
Yeah, you put it into this one, and then you slide it into this one. Now there are set screws inside.
Yeah. So if you were to put this in the middle, you can put like two, one on either side. If you put the rod in the middle, for example, you can put like one here and one here.
Yeah.
sit inside the slots, they can appear unnoticeable at times. With similarities to the plates, brackets, and gussets, these can be more affordable options as they require no machining. They are also very versatile and are great for easier installations. Thank you for joining me today.
All right. So let's look at an example, and then we'll look at the catalog.
With Rexroth's aluminum extrusion, the only limit to what you can build is your own imagination. Keep watching to get step-by-step guidance on how to build virtually anything with this modular material. And as you watch, remember, we offer support or can complete any of these steps for you. So give us a call if you need help with your next project. And if you like this video, don't forget to subscribe and hit the bell icon for notifications. Let's get started with step 1, design. Many engineers get started with step.
So, let me highlight a few features here. This is the cross section of the tube, right, or the piece. This profile is for the head of the screw. So the head of the screw can actually slide in here. I should have brought some samples. We do quite have a few in the workshop. Okay. So the head of the screw can slide in here. So there is another piece perpendicular. This is a hole. You can tap it, so it has threads. And so if you imagine the other one coming from here and the head of the screw is here, then you can tighten against each other. Now, this slot can also serve as for sensor mounting, any brackets really.
1. Design. Many engineers and designers rely on Rexroth's aluminum framing as their project's material, as it simplifies design for any application without sacrificing aesthetic appeal. There's even versions of this material that are rated for clean rooms and medical applications. Some engineers may wish to use their own software for design. This method may be preferred for some architectural applications. But for the planing of most framing systems, we recommend using Rexroth's MT Pro or MT Pro Lite. These softwares include Rexroth's Layout Designer. With this, you can virtually assemble the framing project in a 3D scene with or without generating a CAD model. With MT Pro, you can also access product information. Find the exact framing profiles, lengths, finishes, and accessories needed.
You can actually put in like wire mesh or cage. Like if you remember, all the industrial robot is covered in a cage, and the cage is often like wire mesh. So you have a frame and you put a wire mesh, slide it in. You can also put plexiglass in it, like acrylic, and it can actually act as a door in a way.
For your project for easy ordering. MT Pro Lite is restricted to the Layout Designer, and MT Pro has all features enabled. Both are available for download from Rexroth's website. And remember, you can always call on Airline for additional help. We offer special mounting and hardware that's helpful for custom designs. And our team of engineers can offer assistance or fully supply the project's design, engineering, and installation. With the project's design and list of materials complete, you can now purchase supplies. Airline provides framing materials throughout the Northeast, but can design and assemble projects for companies throughout North America. We offer aluminum extrusion and accessories in a bundle or by the piece. Pieces cut to length with...
In Indonesia, they usually call it aluminum profile aluminum. Actually, profile aluminum, they also come for any other products like kusen jendela, right? The windows with the glass inside. The frame is aluminum, and they come in all kinds of shapes. That kusen, that frame, the door frame, that's an aluminum extrusion too. But in this case, we're talking about aluminum extrusions for machine frames.
Finished machine ends, or as a completed kit. If ordering a kit, all the materials arrive ready to use. Extrusion will be cut to length with machine finished ends, so they're prepared for the included connectors. Everything for the project arrives ready for assembly.
Sometimes you want a rectangular profile so you can mount more things on here. But also think about the loading. Let me ask you this. This profile versus this profile, what is it good at? This one versus this one. What is each strength? In terms of loading direction.
Not sure for the first one.
Okay. If I bend it this way,
That one's the right one.
which one is better?
Right one.
The right one, right? Do you know why?
The more inertia.
What is it called? When you bend something, how the stiffness depends on almost there. Area moment of inertia. Area moment of inertia. And what is the formula for a rectangular area moment of inertia? What is the formula for I?
15,
I know, been 3 years.
1/12 square.
Okay, 1/2. B H
Square.
Q. This is the base. This is the base. This is the H. You know, in the old days in SGU, we used to have the oral final examination where you are tested for the subject all the way from the first semester. Oh. Lucky you, it's no longer here. Okay? But consider this. If this is B, this is H, and that's a formula, which one has a bigger moment of inertia, area moment of inertia, right? For this direction. So it's the same item, it's always stronger when the vertical is taller. Okay? So you look at the bending area, direction. I don't know whether you have it, but penggaris, remember the ruler that is very flexible? It's very flexible this way, it's very stiff this way, right? So, same thing with the profiles. If you think about, like, why do I need a rectangular piece? Well, different reasons. Sometimes you want to mount more things on the slots, you have 2 slots. Sometimes you want the area moment of inertia, so you want more rigidity this way. So instead of picking a big one, do this one. Okay? Now I can always go bigger in all directions, but why would I do this instead of this? I mean, this one also has a big area moment of inertia, right? So why not just make it bigger in all sides? Why only make it bigger this way? Cost, weight, right? Practicality, space. So yeah, you can always go bigger and be stronger, but why, right? It's also the same reason why they make it hollow. Do you know why they make it hollow? If you look at your canopy, I mean, who has a canopy for their carport in the house? Yeah? The frames, they are called hollow, right? The seat hollow. Of course, they meant hollow, but Indonesia, they call it hollow. H-O-L-O, right? Now, these frames, they are actually like this, right? Now, why do this instead of a solid one?
Lightweight.
The center doesn't come in much the air.
It doesn't bend as much. Kalau pakai besi beton kan jadi lentur banget.
No. I mean, a solid, same size, okay, same size, same cross section, but one is hollow, one is solid. What do you think is the stiffness of this? What do you think is the stiffness of this versus this? So this guy can be 70 to 75% as stiff as this one, but the weight is like 5% of this guy. Get it? So what you want is called strength to weight ratio. Strength to weight ratio. You don't. Yes, I do want strength. I do want stiffness. But what is this material doing here? It's not doing anything. Do you remember bending moments?
Maksudnya kalau besi yang di hollow itu kalau dikondens jadi sebesar besi beton doang bulat kecil.
Yeah, but the reason it's stiff is the distance. Okay. Now you go back to strength of material.
Oh my God.
So if I have a beam and I load it like this, okay? Let's say this is solid versus a hollow. Okay, compare this whole situation. These two situations. Same size. If I draw the normal stresses, how do they look like? Do you remember? Do you remember neutral axis?
Oh, yeah, I see one. I see one.
Okay, so if I press on this, it's going to bend, right? Is it tension or compression on the top? If I bend this, on the top is tension, on the bottom is compression. Okay, at least you remember that. So it's tension here, it's compression here, but gradually it's like that. Okay, yeah, starting to come back to you. What is the point here where you have zero stress? In the middle. What is it called? It's called the neutral axis. Okay? Now, what happens if your cross section is like this? So basically, you got some meat on the top and meat on the bottom, right? It's hollow here. It's hollow. So when I compress it or when I bend it, the majority of the tension is here. The majority of the compression is here. Do you see that near the neutral axis, the material is not doing anything? That's why they get rid of the material in the middle, because it's not helping you with the bending. I mean, yes, it's contributing, but not that much. It's not equal. So the top fiber and the bottom fiber is doing the most work. And that's why in construction, I-beams, right?
Bayangin kalau Eiffel Tower itu full solid metal.
So that's why you have I-beams for your construction. Because when you bend this, the top fiber and the bottom fiber is the one doing the work. Okay? The one in the middle is not really doing the work. So that's why you see these aluminum profiles, they are hollow inside, they're thin, but this enclosure will give you the stiffness and the strength that you need.
Pak, kalau besi kanal C keunggulannya apa, Pak? Oh, itu.
The C?
Iya, kanal C.
For what? It's similar to an I-beam, but it's easier to join, I guess. Yeah. For welding practicality.
Flexibility for the connectors.
L.
Everything for the project arrives ready for assembly. Instead of getting a full kit, you can choose to have some or all of your extrusion cut to length by the millimeter, or you can choose machine end finishes, including custom hole drilling, thread tapping, miter cutting, milling, and more. You can also order unmodified aluminum extrusion in its full length, either as a bundle or by the stick. They will arrive in their original length without end finishing, so you'll need to provide your team a list of lengths and machine end finishes to fabricate themselves. Weigh your options carefully and take into consideration your ability to cut and machine your materials. Easily order aluminum extrusion and connector pieces online at www.airlinehyv.com or call us for additional options and specifications. With the materials sourced and prepared, you're ready for assembly. Many assemblers enjoy working with Rexroth's aluminum framing because projects can be built quickly and easily. The framing has a T-slot design, so it's bolted together.
Okay, this is what I talked about, the head of the bolt going to the slot.
Instead of being welded, nailed, or permanently
And you drill on the other side for the access for the tool.
fixed. This provides fast assembly, easy reconfiguration, and in the future the ability to reuse materials for other projects. It also lets assemblers pre-assemble the project in one location, break it down, and reassemble it at the final site. This is helpful for complex builds, like large work cells and automated manufacturing lines. Other projects, like safety enclosures, displays, carts, architectural applications, and others can be built and shipped as needed. At Airline, we can pre-build the project in our large facilities to make sure everything's perfect.
So you can have these cage, right, safety enclosures, simple plastic plates.
Once built, we thoroughly inspect the project through our quality department and provide virtual or in-person inspections from the customer. We can also include accessories for lighting, sensors, conveyors, customized shelving, and more. We can then ship the project, or we can travel to your location to install the framing system. We offer on-site assembly throughout North America and can install framing systems with minimal impact to normal operations. As you can see, there's no limit to what you can build with Rexroth's aluminum framing. Its strength, modularity, and eco-friendliness make it the ideal choice for a wide range of applications.
Everyone can be your source for any or all steps needed for your next framing project. So don't hesitate to visit us online or
Alright, so that's provides you a good overview of what they can do. Let's look at a catalog. From this company, 8020. Okay, so if you go into their catalog, there are different. Okay. So there are different accessories also in the catalog, like a self-tapping end screw, the end cap, so you want to close it so it looks good, right? Quick frame end cap. This is another version of this that is called a quick frame because you can join them using plastic joints if it's a low load, right? So there are other things, support connectors. Okay. So these are the different features they have. So later in the in-class exercise, let's have you build one of these, including the kits needed. Okay.
Doesn't he design these, sir? Were you asking me to design these?
No, I mean like, say you want to build this table using this one. So pick the components, pick the joints you need. Okay, these are just covers on the sides. Okay? So you'll have that exercise later on. Now, when you look at structural design, what you're doing is basically structural design, right? When you design a structure, it comes down to the type and the direction of loading that you have. Remember that you have axial, torsion, bending, and other unique loading coming in. So, what is an axial load like on this piece? Axial means which one? Axial is
Through.
you just pull it, right? If I do this, this is tension, and if I push this way, it's compression. That's axial load. Torsional load, twisting, right? This is torsion. Like if it's a drive axle, you know, driving a car, there's an axle that will twist your wheel, right? Bending, like this. If you want to break this piece, how would you do it? Axial, torsion, or bending? Bending. So, in general, bending is one of the hardest, or the loading you want to worry the most. If you sit on this table, what kind of load do you worry about? Which components do you think will fail? You sit on this. Bending on which one? This part, right? Why? Why not worry about the compression on the legs? Not because it's metal. This is also, by the way, very hollow. Very thin. Chinese stuff, man.
Chinese.
It's called
H times.
Well, because axial load, you don't worry too much about axial load. Okay? Torsion? There is not much torsion going on, I guess. You sit on this one is being bent, and this is thin. They might try to make it thick, but this is relatively thin. it is also helped by this vertical plate down there, like your kick plates there, right? That also helps because it's vertical, remember?
Yeah.
Yep. If you don't have that, this is gonna bend like in no time, it's gonna break, okay? So, you don't worry about the axial compression here, you worry about the bending this way. It also, if I press on this way, by the way, right? If I press on this, there is also some bending here, right? But you got the tulang and sini kan? Yeah. But even if there is none of this one, the moment arm is shorter than this. So you worry about the longest span. Like if you bend this speedo and try to break it, you don't break it this way. You bend it at the edge, right? Moment arm. So same way. Longest moment arm will be the most prone to break. Now, so bending load is one of the harshest things to deal with. Torsional load, you remember how you want, if it is bent this way, the material farthest vertically is the one doing the work, right? In torsion, like when you twist this rod, again, the material doing the most work is the outer fiber. And that's why they often make it hollow also, like a pipe. So your drive axle in the car, sometimes it's solid, but not all of them. The big tube under the truck, if you ever see the kolongnya truck, right? The center shaft, it's big, right? But it's actually hollow inside. Because again, in torsion, the material on the outer edges are doing the work. The one in the middle is not giving you much stiffness. So again, they get rid of it for weight saving. So axial load, you don't worry too much. Bending load. Diagonal brace. Now, this is a unique kind of loading. It's called a racking load. So a racking load is like you push on the top and you pull on the bottom. So like that. Yeah. So you do that to the door. Or let's say if I hold it on this is a racking load. If I pull on the handle but I hold it with my foot on the bottom. Okay? This is a racking load. This is one of the most damaging kind of loading in structures. Yeah, but oftentimes it's kind of an unexpected. People don't expect that a lot. Well, that is one of the weak points. So if you want to test whether a table is good or not, if you go to IKEA to get your workbench, don't try to push down only. Do this, right? So the bottom is constrained. I mean, there is the carpet, and then you push on the top. So that kind of loading determines a lot of the performance in a structure. So if this is the table, you push on the top and the friction keep it on the bottom like this. Okay? So this racking load will tend to make the table goes like that, right? So this is the tendency of the displacement, right? Now, I'm exaggerating, of course, in the drawing. How do you prevent or how do you resist this kind of load? Support. It's called a diagonal brace. Okay? Or, in the case of this desk, do you know what the diagonal brace is? The plate.
Yes.
If you ever try to assemble or disassemble your IKEA products, before you put the backplate in, it's very flimsy. So you put together a bookshelf. Okay, you put together a bookshelf. Like you put everything right, but then it's wanna right. It wanna become like a diamond shape until you put a thin, very flimsy actually, a thin backplate on the back. Right, just a thin, like 2 millimeter. But once you put it as the backing, suddenly it's solid. Because that backing acts like a diagonal. Okay? So, when you design structure, you need to always consider all direction of loading. Because otherwise, an unexpected loading direction will come. So let's say you put like shelves, storage shelves. Okay? That's why many times they have, right? They have a diagonal. And if you don't have that, it's gonna rock.
Scaffolding.
Yes. Now, so this piece is actually a zero force member. Recall that? Zero force member. Okay? A zero force member is actually there is zero force on it, but without that piece, everything's gonna be flimsy. So it's interesting how this works. So when you put a load this way, what's gonna happen to the red piece? How will it react? Tension or compression? Compression. You have good imagination. Okay? So you do this, it's compression. But if you do this one, it's going to be tension. So that's how the diagonal brace kind of resists this rocking or racking motion.
Kalau kayak misalnya tower BTS, mereka pakai kayak kabel itu diagonal gitu.
Not really, but it provides you a good axial load. So yeah, so many towers, anggaplah kayak apa ya, like a tiang bendera ya, flagpole. So let's say for a flagpole, so you're trying to get this piece up, and then the wind starts to blow. So you tie in, right, cable like that. Why do this? Axial load is something easy to deal with. Bending is tough. So this is one of the way you treat that. Without the cable, you have to deal with what? Bending. And it's going to be a very tough support here to maintain. But instead of like having a very big and strong base, I'll just have a small base, but then I'll tie the top to a cable because this will be axial load. And axial load is easy. I mean, again, think about, you want to break something, do you bend it or do you pull it? If you need to break this using tension, it's going to take a lot of force, like 10 times the force. So, yes, axial load, diagonal brace, and also gussets. Now, if it starts to rock this way, and this is not strong enough, what do you do? What do you do to these joints?
Apa namanya? Kalau misalnya beton, dalamnya ada.
Oh, rebars.
Yeah.
Bukan. That's different. In a concrete structure, you have the steel bars in the middle because concretes are not good at tension. Concrete are good in compression, but under tension it's gonna break. But what I'm talking about is called a gusset. Okay? So this piece is called a gusset. Now, a gusset is basically a diagonal brace without the annoying big piece coming across you. So if you need a structure like this, you need it clean, and you don't want any